Hello, hello. Hey, everybody. Welcome to week 5. I'm your professor, Omid Adam Sindhi, and we're gonna talk about the introduction to AI and machine learning. As I mentioned before, this is a very hot topic, and we'll dive right deep into it. We won't go into the deep end of it, since both AI and ML is just super intense. What I'm going to do here in this recording is actually give you a high level overview of common terminologies, common knowledge information that I think will help definitely spark some creativity in your mind to want to learn more about machine learning and AI. So we'll dive right into it. So let's first talk about the agenda, and we're going to talk about some BAU, then we're going to go into artificial intelligence, machine learning, and then we're going to talk about some deliverables. Let's talk about some BAU stuff. So what I want to do is actually talk about SWOT analysis 1. Here are some recommendations that I have for future SWOT analysis. Quality over quantity. I saw a lot of SWOT analysis that have multiple different bullet points and kind of trying to get as much information as possible, but what they were presenting wasn't as sufficient, or I wouldn't say it as detailed as I wanted it to be. So make sure that, for future ones, that you really prioritize quality over quantity. Don't think just having many bullet points will make it look better. I'd rather have, 2 or 3 big points and just, really going in depth about those. But overall, I think everybody did pretty well on a SWOT analysis. This was the first one. I was super impressed. There were some videos that I thought that was, worthy of sharing to a larger audience. So I was very pleasantly surprised. This was the first go around of something like this. So I'm super, super, super happy to see it. And just some requirements moving forward. The works cited page should be an MLA citation. I didn't mention it originally, so I mentioned it last minute. So there wasn't any points deducted, but in the future, I'll put it in the grading where all citations have to be an MLA style, and then any sort of data or text that is being used inside of the paper, please do in-text citations. Because there are a couple of things that I saw that could have been, taken from different sources, but again, I didn't specify, so that's a fault on me. But so no points were deducted. No points were deducted. But moving forward, I will be looking for that if you use any sort of data or any references to any other sort of text. Recordings should stay between about 7 to 12 minutes, 12 minutes max, and that's just because I want you to get in the habit of articulating your point in a very short amount of time, because when you're in meetings, you have a very small window of opportunity to get your point across. And if you lose people early on, then the rest of it is just going to kind of be you rambling on. So try to stick to a script. I think I mentioned to some of you that to take speaker notes. This definitely helps keeps your thought into place. And then also just pace yourself, right? If you feel like you're going too fast, slow down a little bit. If you see yourself not catching a breath, that's an indication that you're going way too fast. But if you feel that you are rambling on, then usually the audience also feels like you're rambling on. So remember, take some speaker notes, breathe, smile. I think there's another thing that I didn't mention here, but moving forward, all recordings need to be done together. I know I mentioned that it can be done separate for this first one, but moving forward, all participants, all presenters have to be presenting in one video rather than multiple different videos. So please coordinate with your partners to just ensure that happens. I'm trying to think, was there anything else? I think that was good. If I come up with anything else, I'll mention it, but overall, really successful. I'm super happy. And I'm excited for the next SWOT analysis that comes in about 4 weeks or so. But now that you guys kind of get the rhythm of it, that's kind of how the next couple weeks are going to be laid out, right? So we have a couple materials, SWOT analysis, more material, another SWOT analysis, and then at the end we have another SWOT analysis. So 3 more to go. So I'm super excited. Thank you. Now let's jump right into it. Let's talk about artificial intelligence. So just as an intro, so artificial intelligence, or AI as it's commonly used, is a field of computer science that aims to create machine capability of intelligent behaviors. Um, Essentially, it's not about making the computers do things that require intelligence when done by human. Um, Sorry, I meant to say essentially this is about making computers do things that are required intelligence when done by humans. This involves learning, reasoning, and adapting. So let's talk about a brief history of it. So the concept of AI dates way back to the ancient myths and stories of artificial beings endowing with intelligence or consciousness by the masters crafts makers. If you ever like the GIF that I had right prior to this is Terminator. If any of you have ever seen Terminator or any offsprings of it, right? I think that was the first major robotics, humanoid robots that really terrified people in the 80s and 90s and even now. But however, as you know, academia sees it that AI began within the mid to 20th century with milestones such as tutoring tests developed by Alan Turing in the 1950s, which proposed a which proposed a criteria for machines' ability to inhabit intelligence behavior, indistinguishable from that of a human. Over the decades, we've seen AI evolve from a simple algorithm to a complex neural network capable of deep learning. Even from what we saw with ChatGPT when it initially launched in the end of 2022, December 2022, it was super phenomenal. But now you compare it to right now, and it's just light years away. And other companies that have done it too, Bard, or I mean Gemini now from Google. And then let's talk about some goals. So some of the goals for AI aims to achieve two primary goals here, right? And we're looking to create expert systems in that exhibits the knowledge and decision making capable. That exhibits the knowledge and decision making capabilities of a human expert. And then it's to implement human intelligence in machine, encompassing learning, reasoning, problem solving, and even understanding human language. These goals are driven by the development of AI technologies that can be argumental into tasks and actually do multiple different things that even humans can't even do, right? And that's to understand complex terminology, complex numbers. Previously, I talked about how some AI, some supercomputers can actually decrypt encryptions that we have now. But again, some of that theoretical, but we can get there. We can get there. And that's kind of the little scary part. Oh, yeah. And that was the last part about the human intelligence. Let's talk about understanding what intelligence actually means. So, when we talk about intelligence in the concept of AI, we're referring to more than just the ability to calculate or process information quickly. Intelligence involves the capability to learn from experience, understand complex concepts, and adapt to new situations, and then apply the knowledge to manipulate one's environment. Now, let's talk about what learning means. So, learning is the ability to improve one's knowledge and skill over time, whether through direct experience, studies, or being taught. Similar to reasoning, reasoning is a process of forming a conclusion, judgments, inferences from facts or premises. Well, now in the context of problem solving, the capability is to find solutions to difficult or complex situations or issues. A key aspect of human and artificial intelligence alike, perception. This involves the interpretation of sensory information to understand and interact with the environment. In the sense of AI, this can mean interpreting data from cameras, microphones, or the environment itself, or and other sensors to recognize patterns or objects. And a few things that I don't have here, but I want to call out is linguistics intelligence. It's to understand that the ability to it's the ability to understand and generate human language. In AI, this involves technologies like natural learning processes, or NLP, which we'll talk about later, which enables machines to read, understand, generate human language in a way that is both meaningful and useful. So I want to conclude with this slide by saying that these components are not just academia or academic categories, they are guides to the development of artificial systems. By understanding and simulating these aspects of human intelligence, AI researchers aim to create systems that can perform a wide variety of tasks, from driving cars to diagnosing diseases. And we'll get a little into that. So now let's talk about the branches of AI, right? So we'll give an overview of machine learning. So artificial intelligence is comprised of a broad range of fields, each focusing on solving complex problems by mimicking various aspects of human intelligence. Today, we're going to briefly explain some of the key branches that have significant impacts on technology and society. When we think about machine learning, at the core of modern AI, machine learning enables systems to learn from data, improving their performance on specific tasks without being explicitly programmed to do so. It's the driving force behind many of the AI applications we're using daily, from search engines to social media feeds. Next, deep learning, a subset of machine learning. Deep learning uses neural networks with many layers, hence deep, to analyze patterns and data. It's pivotal in the advancement in imaging and speech recognitions, allowing for more natural interactions with technology. Ooh, and then natural learning processes, or NLP, as we discussed earlier, enables machines to understand and interpret using human languages. From translation services to voice activated assistants, NLP bridges the gap between human communication and the digital data. And then continuing on, robotics, while often associated with manufacturing, modern robotics integrates AI to create machines capable of navigating complex environments and performing tasks autonomously. From surgical robots to automotive vehicles. So we think about like Tesla. Have you ever seen the video of a surgeon, of a robotic surgeon? It's still in the beta testing. Nobody has been surgically operated with machines yet. Hence yet, but it's coming. Expert systems. So these are AI systems that are designed to solve complex problems by reasoning through bodies of knowledge, mimicking the decision-making abilities of human experts. They're used in areas like medical diagnosis and financial forecasting. And then we talk about computer vision. This field enables machines to intercept and make decisions based on visual data, from facial recognition systems to automated quality control and manufacturing. Computer vision is rapidly becoming integrated to our digital world. If any of you guys have Google Photos, you'll realize that Google Photos can now recognize photos once you teach it what a certain photo is. Example, if I show a photo of myself and I tell Google Photos, hey, this is me, Omid, it will now filter through all varieties of my photos and say, hey, Omid, is this you as well? Just based on a few of the commonalities, few features that it picks up, it can be able to do it, which is crazy. So if you don't have Google Photos, you want to test it out, try it out in Google Photos. But I want to end the slide by saying that each of these branches play a crucial role in the development of the application of AI technologies. By understanding the unique challenges and opportunities, we can better appreciate the depth and the breadth of artificial intelligence as a whole. All right, now let's get into machine learning. Excuse me. All right, let's go from here. So what is machine learning, right? So machine learning is a transformative branch of artificial intelligence that focuses on developing algorithms capable of learning from and making predictions or base decisions on data. It's about enabling machines to adapt to a new situation independently without human intervention. How did this all start? So the concept of machine learning has been around since the mid 20th century, evolving from a simple pattern recognition to a complex algorithm capable of self-improvement. Its development has been uh, propelled by the increase in data availability and computational power. So, what are some types of machine learning, or as we consider it, ML? So, before we get into that, let's talk about the importance of ML. Why is machine learning even important, and why does it matter? At the heart of many technologies we take for granted for today, from personalized recommendation on streaming platforms like Netflix to fraud detections in bank accounts, such as from Chase and Citibank. Machine learning's ability to extract insights from various amounts of data, it's transforming industries and enabling our everyday lives. Now we'll talk about different types of machine learning. So at some of the most common ones, right? So we have what is called we have supervised learning. Hence, supervised learning is where the algorithm learns from labeled training, allowing to predict outcomes or classify data into categories. So we teach it, it's supervised, think of it like that. Then we have unsupervised learning. This type involves algorithm learning from data without labels. So without saying who is what is what type of data it is, and discovering inherent patterns in relationships. And then what we have is called reinforcement learning. So a dynamic approach to where algorithms learn to make decisions by trial and error, receiving awards for correct actions, and much like learning a new game. Understanding these types of machine learning provides a foundation for exploring how AI systems learn and evolve. As we get deeper into specific algorithms applications, remember that these categories, as they are shaped the approach of different technologies and how we have different outlooks. Now, let's talk about some algorithms. So let's go off by giving you a clear introduction of what AI, or sorry, what the ML algorithm is. So as we dive into specifics of machine learning, it's crucial to understand the vast the variety of algorithms at our disposals. Each algorithm has its strength and is suitable for particular types of data and data problems. So here are a few that I'm going to go over. First one is linear regression, used for predicting numbers values based on linear relationships between inputs and output variables. It's a foundation for understanding regression tasks. Logical regression. Despite its name, it's used for classification tasks, estimating probability that an instant belongs to a particular class. Decision trees. These models use tree-like graphs or decisions and their possible sequences. They are intuitive and powerful for classification and regression tasks. Random forest, an assembly method that uses multiple decision trees to improve predictive accuracy and control over fitting. Neural networks. Inspired by the human brains, these algorithms are particularly effective for complex problems like images and speech recognitions, forming the basics of deep learning. Support vector machines, a powerful classifier that works well in high dimensional spaces, ideal for complex classification tasks. Oh, let me put that. And then we have clustering algorithms, or K-means, use an unsupervised learning to group unlabeled data based on similarities. We'll talk about training, validation, and test sets. Splitting the data into these sets allows us to train our models, tune hyperparameters, and then evaluate performance on unseen data, ensuring that our models generalize well to new and unseen data. Understanding these algorithms and concepts is key to navigating the vast landscapes of machine learning. So now let's jump right into, this is some data splitting. Let's dive into the introduction of neural networks and deep learning. At the heart of deep learning, neural networks are algorithms modeled after the human brain architect. Designed to recognize patterns, they consist of layers of nodes or neurons connected by synapses, learning often by adjusting these connections based on input data. So what is the importance of deep learning? Deep learning has revolutionized AI by enabling models to automatically learn from representations from data such as images, sounds, and text. This ability has led to significant advancement in computer vision, speech recognition, and neural language processes, or NLP, making tasks that were once considered challenging for computers now very achievable. So we'll dive into two concepts here. We'll dive into the CNNs, which is specialized in processing structured grid data, such as images. CNN uses conventional layers to capture hierarchies in data, making them extremely effective for imaging and video recognition tasks. And then to the flip side of it, we have the RNN, which is designed to handle sequential data like time series or natural languages. RNN can remember information from previous inputs, allowing them to capture dynamic temporal behaviors. Neural networks in deep learning represents a significant leap forward in our ability to create AI systems that can engage with the world in a similar way to how humans do. By understanding these technologies, we are opening ourselves up to much more of a vast future. Okay, next we'll talk about the applications of AI and ML. So we'll go through some different industries and I'll talk about what are some ways that they're being used in these industries. So artificial intelligence and machine learning has found an application in nearly almost every sector of society and industry, transforming the way we live, we work, and interact with the world around us. Right now, let's explore some different industries and what AI and ML has done for it. First, we'll talk about healthcare. In healthcare, AI and ML are revolutionizing diagnoses, patient care, and treatment planning. Algorithms can now analyze medical images with accuracy comparable to or even exceeding human experts, predicting patient outcome and personalizing treatment plans. In the finance world, they leverage AI for fraud detection. So, like as I mentioned earlier about banking, risk management, and algorithmic trading. Machine learning models can identify patterns indicated of fraudulent activity, assess credit risks, and make high frequent trading decisions in milliseconds. In the automotive vehicles are perhaps one of the most talked about applications of AI. Through a combination of sensors, data, machine learning algorithms, car can now navigate complex environments, make decisions in real time, and ensure patient safety. Here's some more industries. In the sense of entertainment sectors, recommendation systems can use streaming platforms like Netflix and Spotify to personalize content for users by analyzing viewing or listening to habits, improving users' engagement and satisfaction. AI and ML are also transforming manufacturing through predictive maintenance and quality control. By analyzing data from machinery, algorithms can now predict when a machine is likely to fail or identify defects in products, often more times in real time. These are just some examples of how the tip of the iceberg that AI and ML technology has continued to advance all these different industries and more that I haven't mentioned here. We can expect to see more innovation application that will further change in the landscapes of various industries. So with all the great stuff here, we have to talk about some of the most basic ideas, and that is actually some ethical considerations and the future of AI. So as we integrate AI and ML more deeply into our lives, it is important to address the ethical considerations these technologies raises. Issues of biases, privacies, and impact on societies are often the forefront of ongoing discussions in this field. As AI systems are only as unbiased as the data they are trained on, there are numerous instances where AI has had prejudice or even exhibited some biases, leaning to unfair outcomes. It's crucial to develop methods to detect and mitigate biases within AI models. And then we think about the privacy concerns. With the vast amounts of vast amounts of data used into training ML models, privacy concerns are inevitable. Ensuring that the security of this data and using it responsibly is a significant challenge for AI developers and policymakers alike. As I mentioned earlier with the Google Photos, right? What am I doing? I'm training the model to recognize who I am, but I'm feeding this model multiple data points. And that can be through my videos, that can be through my images. And, at some point, right, think about the privacy aspect of it. How much of my data is out there in the world? And, what are the likelihoods of it ever being compromised? These are things that we think about. Some societal impacts is that the impact of AI on employment and society as a double-edged sword. While AI can now automate routine tasks and improve efficiency, it is also raising concerns about job displacements, as we are seeing in the current market right now. It is vital to consider how we can leverage AI to enhance human capabilities rather than replace them. Right now, AI and automation has completely taken over some of the tech world, and we need to understand what we can use AI for to help us continue our work rather than just replace us. And when we think about the future aspects and future prospects of AI, we look we look forward we look to the future of AI as both an exciting and uncertain advancement. Advancements in AI could solve some of the world's most pressing challenges, from climate change to healthcare. However, navigating the ethical landscapes will be key to ensuring that these technologies benefit humanity as a whole. So now, with everything that I've been teaching you here, you may be thinking, okay, Professor, you're talking about AI, you're talking about ML, but what can I really do to learn this? So some skills that I want to talk about, but not limited to, is a strong foundation of mathematics. In the world of stats, probability, and linear algebra, it doesn't mean that if you don't have these things that you cannot get into the world of AI or ML. These are just some things that if you have a great strong foundation with, you'll do pretty well and be pretty successful. But again, it doesn't restrict those that don't have this ability. You can definitely learn it and become good at it as well. And then we think about programming. Right now, AI is very big. AI and machine learning uses Python as an essential way of its deployment. And then we think about tools, right? So let's talk about some of the tools here. So familiarize yourself with some key ML libraries and frameworks, such as TensorFlow, PyTorch, Skitzy, scikit-learning. These are some frameworks that can help you definitely learn more about AI models, and they're just more so the building blocks of how to get there. And now you're going to ask me, okay, what can I do to actually learn more about it? So there are AI courses and machine learning courses here at the university. Definitely check them out if you have the opportunity. If not, you can definitely check out Coursera. Whenever I'm in a rut, I just go to Coursera, or just some other free resources like edX. They will definitely have some free courses that you can get from Yale, Harvard, MIT about these certain topics. and then etc. Right? So this is just more so join some AI communities, attend some workshops, maybe some hackathons that can help provide more practical experiences and networking. You want to learn about it, network with people that know it, and get to know them. But just remember that the journey into AI and ML is a marathon, not a sprint. There's so much to learn that you need to take a breather and understand where to start, and where first think about what's your goal, and then where to start. Just start anywhere, to be honest, and then work your way up. So stay curious, be patient with your learning process. You will not get everything all at once. Even for myself, it is, a learning process to understand all the different concepts that are happening. And don't hesitate with the community. Don't hesitate to come out and reach out to me. The field is rapidly evolving, and that one thing can be true today, but it won't be true tomorrow. So continuously learning is a key to staying ahead of the game of all the new developments that are happening.